9,000 times 60 mils. 9,000 times 0.06. 540 watts. And we should be able to get some spark off of this 540 watts. Obviously, we're radiating a considerable amount of energy. In fact, I don't even mind pulling some spark off of this. I don't think. If I have a pole or something, maybe I can do that over here. Stand on.
Want me to operate the?
Yeah, might as well. Just make sure to keep a hand on that switch in case there's a problem. Go ahead and turn it on up till it fires.
You want to turn the lights out?
I'll do the lights on here first. Turn the lights on, I'll give them a shot with that.
Okay.
Alright, go ahead and fire it up.
Firing.
So we're getting about a foot of spark off of this system with only 540 watts put in, which it says something, even though the system is very large, it says something about the Q of the system. I think at 540 watts, and that's a hot spark coming up.
Okay, easy does it, Rich. Easy does it.
Yeah, better do easy does it. So I'm taking a little turn off. Go ahead and kill it. Save as much tape as possible. Okay, the tape turn on. That was worse.
Yeah. Raise the frequency of the primer. Okay, we just took one more gap out. We
One more turn.
made the primer at a higher frequency. Let's see if we need to tune it further.
Lock it.
How about bringing the tripod and I make an exit?
Yeah, we just put in a strike shield down here to protect the tank circuit and the front end of the capacitance, because we're going to move up a little in power and we're getting our tune a little closer to right on the money. Go ahead and shut down. There's live again, 92.5.
Watch, you're overcoupled. I saw 2 brakes on the other side there.
Right. Yeah, we made a slight adjustment to the secondary. We raised it up with some additional wood blocks and about another 3/4 of an inch. As Gary saw a couple of splashes down on the secondary here on the back side of the coil.
They're always in the back, you know.
Yeah. So we'll go ahead and give it a shot here again. Check that coupling. We just uncoupled it a little bit with a couple of Did you see any breakdown in the secondary?
I didn't, but I wasn't looking that closely. I'm kind of standing back a little.
All right, well, let's take a break. Unpause. Yeah, we're increasing the current slightly. We're adding about 20 amps worth of secondary current into the current limiter. Give us a little more output here. Everything looks pretty smooth. Shall we go a little higher?
Go ahead. That's like a 10% boost right there. Deafening loud.
Let me see. We take a break for a second, huh?
Recording.
We're at about a little over 90 secondary amps.
See no point on setting the ceiling on fire.
Neither do I. I don't see any point taking it.
I smell burning wood.
Yeah.
Oh yeah. Yeah, well, I feel heat. Hold on, let me turn this off.
prove my point.
Yeah, before we get molten, burning tungsten bars shooting around here like hot rifle bullets.
Just leave it rolling.
Okay.
Just leave it rolling.
Well, folks, what you see is what you get tonight.
That was the... As I increase power, the gap performance, the coil performance is dropping off seriously. And the reason the coil performance is dropping off seriously is because that gap is not quenching. It gets up to about half power and it's quenching okay, and I'm getting some breakout from it that's pretty, decent here. But then I add more power and all of a sudden that gap is overloaded. It's quenched out. Yeah, it's choked with ions and it's not performing. So what I'm going to do here, I'm not going to change anything at all in the tank circuit. I'm simply going to move this down here. I'm just going to switch in my other gap. Now, let me tell you some specs on this while we're rolling here. This gap has only got 5 electrodes in it, and there's only 4 gaps. And the spacing between each gap is 0.020. So we have less gap distance in here and fewer gaps than in the static gap unit we were just running, okay? And so theoretically this gap should not even perform as well as that because the breakdown voltage on here is lower. But we'll plug this in. The vacuum unit's running. We'll turn the light out. Getting some good airflow through here. You can definitely feel it. There's air cruising through those electrode faces. And then cut back on the light a little bit.